with all what you have learned earlier, we are ready to attack exam questions. So let's go. So right now the Routh stability criterion actually applies to first and second order system. So as you remember, first and second order system, what are the key rules that we're talking about? Okay, all coefficients are positive, right? And then there is something that they didn't explicitly describe here, is that k should be a positive value. Okay, it should be larger than 0, and therefore we have answered the first question. Okay, so k should be positive and should be larger than 0. Okay, coefficient should be positive and k should be larger than 0. Okay, coefficient. Okay, the coefficient here for here, So let's tackle this question. Okay, so if you have a s squared plus 2s plus k equals to 0, what are you going to do? Okay, so you have to first, so you are given already the characteristic equation, as you can see, characteristic equation. So what does this mean? Okay, so this means that they have already skipped the steps for you already. So they already do this thing, and then eventually you get this as the denominator. Okay, so in other words, they actually provided you with the denominator over here. Okay, they actually, because typically if you're gonna solve, you have to solve using the transfer function, and then you do the closed loop unity, and eventually you can get the denominator over here. But they actually give you the denominator itself, and you solve it yourself. Okay, so what are the ways to actually solve it? Okay, using our Routh method. Okay, so you can see that since it is second order, you should have a two equations, I guess. So actually not lah. Okay, so previously I said that first order you use, so second order you have two k equation, third order you have 3k equation. Actually it's rubbish lah. So this is just one example already, you see. But anyway, so in this case there is only 1k, so we can just say that k should be must be larger than 0 using our understanding. And you also have to state that all coefficients are positive, and then so therefore it is stable. Okay, so you have to really check it out for that. So this is really, we have 2 marks for this already. Okay, so for part 2. So for part 2 is a third order equation. Okay, so if you remember, our third order, it should be positive, and it should have a1 times a2 larger than a3 times a0. If you remember our third order system, all coefficients are positive, and a1 should be larger than a0a. Okay, with this set, what you're gonna do is this. Okay, so hold on a while. So to following this equation, this understanding, a1, a2, it should be larger than a0, a3. There will be a 3 over here, but there's a typo error. So so in this case, let's head back to our system. Okay, I actually write down. So the first we already made it. Okay, all coefficients are positive, and you can identify that there is actually no second order. There is no s squared or something. That's s squared is 0. So a1, okay, a1 is actually the first order, right? So it's 4 plus k, while a2 is 0. So as you can see, if there is a 0 multiplied with 0, you have anything minus 0, you have 0. So it is not larger than 16k, you see. So a0 is actually 16k, and then a3 is this one, which is like 1 coefficient, because there is no any maybe 8s cubed or whatever, but now it's 1x cubed, so we want. So if this set, you can say that this distance is not stable. Okay. So part 3. This is a third order system again. Okay, s cubed is the highest order, and then you can see that there is second order, there is first order, and there is 0th order. Okay, so if you have to go head back to third order system again, what is the criterion? Well, all coefficients have to be larger than 0, and a1, a2 has to be larger than a0, a3. Okay, so let's do it out. So to make things a little romantic, okay, I'll just show you will have pink color. Okay, so first thing you need to write is actually all coefficients are positive. Okay, and then the second one, you have to prove that A1, A2 is larger than A0, A3. So in this case, A1, what the fuck is A1? A1 is actually this K1, the first order coefficient. So you have 4 plus K, and then you have A2, where the fuck is A2? A2, 4. And then A0 is 8K, and then A3 it's 1, right? So from here you can see that, what do you see? 4 times 4, 16, plus 4K. You have 8K over here. So from here you can, although it is in terms of K, okay, it is not compulsory stating that K should be, not stating that this thing will be definitely larger than 8K, okay, because K may have some values that is, maybe K is 10, okay, and then this whole thing will, and then we will be unstable. So in order to do that, we have to determine the value of K, okay, in order to prove that this system works, provided that some values of K are put in. So you give me a while. To start, we have to do the interval. Okay, so A0 is equals to 8. A0 is actually equals to 8K, but nonetheless, 8K has to be larger than 0, right? So K has to be larger than 0. In this case, only K determines whether it is larger than 0. So A1, it's first order, right? So 4 plus K should be larger than 0. So if you were to bring the 4 minus over here, you have minus 4 over here. So we A2. So you have A2 second order. So it is actually, there's no K, right? Good job, there's no K. So we can just don't care about it. So with this, we have two values of K, okay, which is K larger than minus 4 or K larger than 0. Okay, so from here you can actually straight away see that K should be larger than 0. But nonetheless, if you draw the number line, okay, so for K it's 0, it's going to infinity, right? If it's larger than 0, so if K is larger than minus 4, so it's whatever values across this number line can be used. So the best range is actually from here that satisfies. So the best K value that satisfies both lines is actually this portion over here, right? Okay, so yeah, so this numbers larger, so K larger than 0 can satisfy all these things. Okay, so from here, you can actually, so the next parameter that you're gonna talk about is actually this dude over here already. Okay, so you also have to set up the range. So what is the range? Yeah, I actually forgot. I should do it this first. Okay, anyway, so if you bring 16 over here, okay, what do you have? You have 4K, and then if you bring down, so it should be so so K should be smaller than 4. Okay, so in this case, what we have done, okay, we just rearrange and stuff like that. You can see that K should be smaller than 4. So where is 4? So let's put 4 over here. Should be smaller than 4, so it goes to the negative area. So what satisfy all these things? What satisfy all these boundary conditions? Okay, this region over here, right? So K should be smaller than 4, while larger than 0. So the best range should be this. Okay, so if K is within, so K can be 1, can be 2, can be 3, cannot be equals to 4, cannot be equals to 0. So if you sub in 1, 2, or 3 in this equation, okay, in this characteristic equation, okay, you have a good outcome, which is stable anyway. So with this, hold on a while again. So we have part 4. Part 4 it is a fourth order system. Okay, highest order is 4. So therefore, when you come to here, you will go to here. Okay, so it's a fourth order system. Okay, I mean you have to go to see the rules. So my rule states that if higher order system, meaning higher than third order, okay, which is fourth order, which is fourth order and higher. So all coefficients should be positive. Elements of the first column in the Routh array are all positive. So meaning all this you should put it as positive. And then the requirements of first, second, and third can be also shown from the Routh array. What it means is that you can also use Routh array to actually solve for this thing, but you know, since we can solve it so easily, simply, so you can no need to use Routh array, unless you know, it may be some complicated stuff. But nonetheless, let's start. So you can see that the all coefficients are positive. There is nothing at all. So you know that if it's fourth order and above, you need to use Routh array. So let me write Routh array. The number of rows is determined by the number of order plus 1, right? So in the number of order, in this case is 4, so we have 5 rows. Okay, so we have 5 rows. Although this equation, I don't know, but yeah, the number of rows should be equals to n plus 1. It should be this equation. Anyway, so we have S4, S3, S2, S, and then S0. So we have this over here. And then what we're gonna do is to plot in my thing. So as you know, this is, maybe I should plot it out. This is A4, this is A3, this is A2, this is A1, and this is A0. So let me plot it out. Okay. So A4, the highest should be plotted over here. So it's 1 coefficient because there's no coefficient over here. And then A3 is 2, right? So you just plot it down. And then for the second order, lower order from A3. So then this is 4 plus k, and then this is 8k. Alright, so let's start off with the Routh array. You have 2 times 4, okay, 8 minus 1 times 4 plus k divided all by 2, okay, and then as for the other one, 2 times 8k, so we have 16k, and then minus away 1 plus 4 plus k divided all by 2. Alright, so I'll just solve this. Okay, later I'll just come back. Hold on a while. Thing we have to do together, so let's do, and then 8 minus 4, okay, and then you bring this minus also, so it's minus k divided by 2, and then you have so 8 minus 4 is actually 4 minus k divided by 2, okay, and then 16k, okay, maybe I should write different in 16k minus 4 minus k, okay, and divided by 2. What do you have? You have 15k minus 4 divided by 2. Okay, so with this you can actually have the value for S, for the S2 and S1. Okay, so now let's do it again. Okay, so hold on again. By the way, do you see something wrong with my workings? Okay, so actually this portion is actually wrong. Okay, I just realized what is wrong. Okay, what is wrong? Okay, if you remember our Routh array method, this times this, okay, 2 times 8k minus away 1 times some values over here. If there is not, then you know it's 0, and then divided back by 2. Okay, so in other words, it should be 2 times 8k divided by 2. Okay, so 8k minus 0, since that 1 times 0 is 0, so therefore we have 8k over here. Okay, this is a very vital mistake, so make sure you know. Okay, so as you can see, my basics aren't right yet. So with this, let's continue. So you can see that 4 minus k over, maybe I should bring all of this out. So you have this value over here, and we have 8k. So let's do it up again. So maybe I should use the romantic color again. So 4 minus k, 4 minus k, 4 plus k. And see this minus away 2 16k. Okay, divided everything by 4 minus k divided by 2, and then 4 minus k times 0 is nothing. 0 minus 0, so there is nothing over here, right? So this is the value for s. Okay, so as you can see, we have solved so much. Okay. So nonetheless, as I say earlier, your your S0, meaning 0 order, okay, should be the same throughout. Okay, should be 8k in this case, because this one times this one minus away this one times 0, there's nothing over here, divided by this one back again, you have 8k. Okay, if you remember, so this portion times this one minus away this portion times this one, then typically this one will be 0, right? So only this times this, and then you divide it back by this one. You get what I mean? So you get 8k back. So this is why we have this value over here. I mean this array over here. The only hairy portion is over here, and you can solve. So you give me a while again. Just to reinforce, yeah, is that if you don't see, because just now I have some equation over here that are calculated wrong. So nonetheless, I realized that if this equation, if this multiplied by the wrong equation, you'll not get back 8k. So this is why I realized that, because because in the end, this zeroth order has to be 8k. Okay, has to be the same as your a naught. Okay, because your a naught will travel all the way down over here. So this is the portion where you can actually check whether your Routh array is it wrong. Some calculations, So this is just one key process. But nonetheless, I thought it would be good for me to actually do review for this one. So you can multiply throughout everything by 2. So I just cancel away the 2. So you have so I just multiply everything by 2. Okay, so you have 4 minus k, 4 plus k minus 32k divided by 4 minus k. Okay, and then the rest I think you should understand how it works already, and eventually you will get some values. Okay, so hold on a while. Now you will eventually get a quadratic equation at the numerator, where we have a denominator 4 minus k. Okay, so I just do this thing. It's pretty hairy, but as you can see, it is the same concept where you eventually you derive for the previous one, that's not the equation for the fourth order. Our example, okay, you have this thing again. Okay, so that when you know this, and then so the next step is actually what we're gonna do. Since we have to identify all the k equations. Okay, so with this case, how many equations do we have? Okay, so I see that I have this equation over here. 1, we have 2, we have 3, and we have 4. Okay, so we have 4 equations of k, and then we can solve for k. I think I'll just do it in the next video, and then I'll call it a day, and then nonetheless I'll do a summary before I end. So yeah, see you there.